Hey friends, so basics of SPSS part 2. What I want to do is take some time to actually move through the output window with you. So we talked about it in the previous lecture that you'll run certain analyses. Sorry, I'm petting a cat. There's a cat down here that wants my attention. You're running certain analyses, and then what happens is on your output window or your receipt window, however you want to describe it, it tells you what you ran and what the results look like. So what I've done here is I've got a data set. This data set's called film data, and a stats class and I built this. God, it's got to be. Oh, there's the cat. All right, here he is now. This is Binksy Cat. Built this data set about 10 years ago using some of our favorite movies. And essentially, what we're doing is trying to figure out what factors predict whether or not a movie is going to make any money, right? And so I've run some basic analyses here just to kind of get you familiar with what this window is going to look like and what you do with the different variables and values you see here. So, for example, this first analysis. I'm going to circle it here with my cursor. There's the correlation. And in this case, what I'm doing is I'm correlating a film's budget, so how much money it costs to make the movie, with the income, or basically how much money the movie makes. And this is just domestic. This isn't international gross or international budget, just a domestic product, domestic numbers here. And so what we're doing, if we follow this over, when you go to read this, it gives you three things. It gives you the Pearson correlation, which essentially is also referred to as the correlation coefficient, and that is represented by a lowercase r. I know some of this might be a statistical review from back in the day, but when you go to provide these values in your thesis, you'll label this as a lowercase r, all right? Oh, and by the way, all of these statistical values are always italicized. So lowercase r italicized. Make sure you don't confuse it because actually capital R is for a different statistical analysis, regression in fact. So here's our R value here. Just below that is our significance, which if you think back to stats is represented by a lowercase p, once again italicized. And then we've got n. In this case, n represents, oh my God, there's another cat, represents sample size. And usually a sample is represented by a lowercase n. And population is represented by an uppercase N. But because SPSS doesn't know if this is a sample or the full population, it designates it as a capital N. Anyway, the N represents how many data points were utilized in this analysis, right? So we'll start there. We'll actually work backwards. So I like to follow it over. You'll notice that this table is actually a mirror image of itself. So the same numbers you see here, the same numbers you see here. And if you see this 1, you might think, why is it 1? Well, it's basically budget correlated with itself. So of course, anything correlated with itself is going to result in a perfect correlation or a 1 R value. So we'll follow it over. Here's our lowercase n. Follow it over to this square here. And notice our sample is 96, which means there are 96 movies that were used in this correlation. If we go up slightly, this 0.000 is our significance, our p-value. And if you think back to statistics, we want our p-value to be as low as possible, right? So we want it to be below 0.05. And hopefully you remember that from stats. If that's the only thing you remember from stats, that's fine, because that's the most important part. But p needs to be less than 0.05, which means we have a very, very small possibility of error. We'll just leave it there. I'm not going to go into the full description of it. And if you notice in this case, our p-value is listed as 0.000. Let me caution you on this, because this actually doesn't represent a p-value of 0. So if you put p equals 0, that's actually incorrect. What it's saying is the p-value represents less than a 1 out of 10,000 chance, or rather, excuse me, less than a 1 out of 1,000 chance that what we've seen is due to error or a fluke or an anomaly or something like that, right? So doesn't mean it's actually 0, it just means there's a 0 in all 3 of the first decimal places. Kind of a quirky, geeky stats thing, but just make sure you don't put p equals 0. What would be more accurate in this case is you would put p equals 0.001, or p is less than 0.001. That's going to be a more accurate way to describe it. So in this case, we have a significant correlation. We know it is significant. Significant because of the p-value, right? And if we go slightly upwards, here's our R value, so 0.754. And if you think back to what correlation looks like, 0.754 is pretty good correlation, pretty strong correlation. Because it's a positive number, it's a positive correlation, or what's called a direct, I prefer the term direct, a direct correlation. And what this essentially means is one variable goes up, the other variable goes up, right? And likewise, as one variable goes down, the other variable also goes down. So essentially, they're moving in the same direction, either up or down. And so what this is saying to me is that there's a significant, direct, strong correlation between budget and gross when it comes to making movies, right? So let's translate that. Essentially, that means that the more money you pour into a movie, the higher the budget it has, the more money you could expect to get out of it in terms of gross. Likewise, if you have a low budget film, you probably don't expect to make a whole lot of money out of it. And of course, this is not causation, this is still correlation. So you might say, aha, but what about the Blair Witch Project? Or what about Paranormal Activity? I think Paranormal Activity had a budget of like 30,000 and made, I believe, 12 million in the first weekend. It's by ratio the most profitable movie ever made, right? So in that case, of course, there's some anomalous data there. You could say, well, those are exceptions. Yes, but the rule is you want to make a lot of money, you got to put a lot of money in. So that's just a quick rundown of correlation. If we go below this, what I did was I did a t-test, an independent samples t-test. And I was once again looking at income, how much money movies make. But in this case, I compared animated movies and dramas. So I'm looking at two separate genres of movies and saying, okay, can I make more money with an animated movie or do I make more money with a drama, right? And if we look at the data, so it's, I apologize, it's scientific notation here. But if we look at the data, we're talking about a profit, an average profit in dramas of, what is that? 87 million, right? $87 million. If we look at the average profit for these animated movies, we're talking about $200 million. So if you just do this, simple, math on it, 200 million, if somebody says, oh, is there a significant difference between 200 million and 80 million or 87 million, right? You'd say, yeah, that's a good difference. That's a pretty substantial difference. And so we're already expecting it to be a significant difference. And if we come down here, so here's the means. These are the averages for the movies. And then if we come down here, we follow this top line. I'll talk more about that in a second. And there's the significance right there, 0.015. Okay, and what that means is our p-value is 0.015. P-value is, of course, going to be given in all of these. There's the p-value there. Here's the p-value here, 0.015. And of course, that is less than our threshold of 0.05, right? So in this case, we do have a significant difference in profit from animated movies to drama movies, right? In this case, animated movies make significantly more money than dramas. Right? So that's what this test reveals to us. There's other information that's embedded in here. If you look, once again, the n value. So we only had 10 animated movies in this data set, but we had 52 dramas. So already it's a little bit questionable because we can't say we have fairly limited data on animated and a decent amount of data for drama. So it's hard to say, yeah, are we seeing a really good trend? So there's a little bit of questionability there. There's the means for both of them. Standard deviation and standard error of the mean, we're not really going to talk about in here, but I would invite you to revisit those back from stats. They usually, some students will need them for part of their chapter 4, but many will not. So just have a look back at this, and if there's any question about whether or not you need to consult with your professor for this course, or you can always reach out to me. When we're reporting this too, we actually ignore the F value and we ignore this significance. This significance actually pertains to this F value. We don't need that. We're not worried about an F value when we're doing a t-test, of course. We're looking for a t-value. And so there's the t-value we would report, 2.49. We have 60 degrees of freedom, right? Because we have a total of 62 in our sample minus 2 separate groups. So 62 minus 2 is 60. And there's our significance. And you might be saying, well, we've got 2 t-values and 2 significances. Yes, but we always use the top line. The bottom line involves, it's a little bit more theoretical, and it's often less accurate. So I always tell my students, only stick to the top line. This is really only one you want to utilize. So there's the t-values we need for this. When you look at these, by the way, don't be overwhelmed by all the numbers. You might think, oh my gosh, look at this, is just, these 2 tables represent just a single analysis. Look for what you, know what you are looking for and look at that first. Right? It's easy to just look at these and be like, I don't even know how to make sense of any of this. Of course, if you look at all at once. But if you know what you're looking for, it becomes much easier. That's why I say, look at the means, look at the sample size, come down here and look at the t-value, look at the significance. And for a lot of stuff that you don't know, ignore it. Ignore it. Much of what this provides you with is not entirely necessary for what you're doing. So let's look at one more together down here at the bottom. What I did was actually run a one-way ANOVA, comparing how much money the movies make, so their income, based on their rating. So here it is, G, PG, PG-13, R, not rated, right? So I've broken them down this way, and I'm looking for what's called a main effect for film rating on income. So the question I'm essentially asking is, does the movie's profit have anything to do with what kind of movie is being made? And most of us would say yes. That would be the kind of default answer. But what we're asking, as always, is does the type of movie being made have a significant effect on profit, right? So I'm going to look over here at the mean. So here's this the end values, right? So notice the distribution here. We got a lot of rated R movies, quite a decent number of PG-13s, but very few Gs, PGs, and of course not very many not rateds. But if you look at these, we can actually see a pretty substantial difference in what they're making. R's on average make about 766 mil, which is solid, obviously. Is that 766 mil? No, that's 77 million, excuse me. 77 million. And then if we look at PG-13, they're averaging about 300 million. Ooh, there's the cat again. 300 million, right? So we're seeing a massive difference. But if you also look, G and PG make well over 100 million as well. So if we come down here, we'll hop down this way. Here's our F value, which in ANOVA, we always report the F value, right? And then here's our significance, 0.000. And just like we talked about with correlation, what we would say is, in this case, our significance is not 0. It's just less than 0.001 or equal to 0.001 is how you could list it, right? So yes, we are seeing a significant main effect of film rating on gross income. Right? So, and we could say, it seems like PG-13 movies tend to make the most amount of money compared to all the other film types, right? And what I would love to see you do in chapter 5, so chapter 4, you just provide a description. You'd say that there's a significant main effect of film rating on income, right? And you wouldn't say much more beyond that. You might say, that PG-13 movies make the most, right? In chapter 5, when you're talking about what this actually means, you might say PG-13 movies probably make the most money because they have arguably the largest audience. Because you have parents who will go see it, teenagers who will go see it. Many parents will bring their kids with them, right? As opposed to R movies where you're going to see you shouldn't see any kids, but you're going to see a lot fewer teenagers and a lot fewer kids, just adults, right? And likewise with G and PG, you're not going to see a lot of teenagers. So it's really that kind of wheelhouse where you're going to get the largest potential audience base. And this tends to increase the profits. And if you look at movies that carry a PG-13 rating, we're talking about, the Marvel Cinematic Universe. We're talking about the Star Wars universe. We're talking about all sorts of like action movies. I think all of the Fast and Furious movies fall into that category. So movie franchises that make a lot of money tend to fall into this rating. But those are all insights I'd love to see you provide in Chapter 5. And hopefully what we've discussed today kind of gives you a little bit of a crash course on how to interpret SPSS outputs and what you're looking for when you run these analyses so that your Chapter 4 and your Chapter 5 will go all that much smoother.